The last part of this module, the third part on human variation, is going to cover additional patterns of variation. We're going to discuss some of the individual adaptations that we see among human populations and other animals, as well as things like acclimatization. One thing we notice at the population level, both in animals as well as applicability to humans, are Bergmann's and Allen's rules. Bergmann I'm going to show first, and then we'll go to Allen's rules. I usually remember them. Bergmann's has to do with the body. Allen's has to do with the appendages. When you look at Bergmann's rule and you compare animals of very similar species and evolutionary history geographically, what you typically notice is that individuals that are in higher latitudes, more northerly climates, they have larger body mass, so that they can give off less body heat per unit of mass. This means they have a lower surface area to volume ratio. So in warmer climates, it's about, being smaller, more nimble to whisk away heat. In colder climates, it's about having a larger body size so that you can retain heat. The example I have here is a deer that is native to Nicaragua compared to a deer that's native to Michigan. The deer in Michigan has much larger body size than Nicaragua, and we don't think this has to do with diet, because that would also affect size. We think this has to do with climate adaptation. Allen's rule has to do with the appendages, forelimb, hind limb, your arms, and your legs, but it can also be other limbs, like you'll notice with the example here, the rabbit's ears. What you'll notice with Allen's rules, another continuum or gradient similar to Bergmann's rule, but remember, Bergmann's has to do with the body, Allen's has to do with the appendages. Limb surface area to volume ratio gets smaller in colder climates, and so what you'll notice is in more northerly latitudes, colder climates, the appendages will be smaller and they're closer to the body, kind of tucked in. In warmer climates, we tend to see longer limbs, more elongated, and then further away, extended from the body. So if you look at the rabbits here, all four of them, on the far left, A is an Arctic rabbit, a rabbit from the subarctic, and then you have from left to right, a very common American rabbit. You have a rabbit that's native to California, L. californicus, and then you have L. alleni, which is a desert rabbit that you'll find out here. If you look at the desert rabbit and the gradient in comparison to the Arctic rabbit, look, the limbs are much longer, even the tail is longer, and even the ears are elongated. Yeah, we're getting to the point here in terms of human variation that yes, we do see a general pattern that is associated with latitude among human populations. Individuals that are in higher latitudes, more northerly climates, typically have a short and stocky build that conforms to Bergmann's and Allen rules. In Africa, people that live very much closer to the equator in hotter, more humid environments often will have a more elongated body form, body size that's not as stocky, and typically nice long limbs. So you can see somebody from Africa and the Arctic have different body forms, and this likely conforms to latitude and climate. The last topic I want to cover is acclimatization, and this is where your body, and this is individual, will physiologically adapt to an environment. And these are traits that typically are plastic, meaning that they have flexibility, can change. So phenotypic plasticity, or something phenotypically plastic, means that it's a phenotype, right? Something we can see, but then there's flexibility, meaning that the environment can change the phenotype. Your skin color is a really good example of something that is phenotypically plastic, where your skin color changes over time based on your sun exposure. Yes, you have a general skin pigmentation color that exists, but if you go into the sun, you get darker because your body reacts to increased solar radiation and produces more melanocytes to produce more melanin and protect you from solar radiation that can burn up all of your folate reservoirs, as well as potentially contract skin cancer. So your skin color, you have the ability, think about it. You just don't all of a sudden get skin cancer. Your body has a mechanism to try to adapt to that. Also, you will produce more sweat glands per follicle if you move to a much warmer environment. So I know me moving to the Valley of the Sun probably about 10 years ago, it took me a few summers of heat to really get used to it. And that probably was my body, because it's only like short spurts of a few months, to actually move into overdrive and produce more sweat glands per follicle so I can adapt to this area. Altitude adaptation is usually one of the most classic examples of acclimatization. With time and exposure to areas of higher latitude, it typically has to be at least about 10,000 feet. You will notice an increase in red blood cell count, hemoglobin, lung size, as well as heart rate. And this is something that takes time to accumulate. For instance, Mount Everest is it's over 20,000 feet. If you want to climb Mount Everest without supplemental oxygen, you actually go up to 10,000 feet and you stay there for about a few days or a week. And then you go up to 15, then to 20, and then you ascend to the summit. And each one of those stops, you stay there for a few days or a week for your body to acclimatize. Because if you just keep climbing up straight every day, keep going, you're probably going to die because of depleted oxygen. The air is much thinner, and your body needs to increase its red blood cell count, its lung size, in order to be able to survive in that environment. And I want you to understand that this is short term. You don't climb Everest and like if you went to go climb Mount Everest right now, we could measure your red blood cell count, your hemoglobin count, as well as your lung size and heart rate. We let you go to Everest, climb Everest, take you about a month to do. You come back, we would actually probably see an increase in all of those measures we just recorded. Now, we would record those measures after you came to the Valley of the Sun, maybe a month later, and actually you would lose your increase in lung size and red blood cell count and hemoglobin, because now your body realizes that it doesn't have to work as hard, right? So that's why this is a temporary physiological adaptation to environments, because your body is only going to do as much work as it needs to.